So, just like not all volcanoes are the same, not all hazards are associated with volcanoes. Not all volcanoes emit lava. Not all volcanoes explode violently. So we had to understand the different types of volcanoes, why they're that way, to understand the hazards. So let's talk about those. All right. So by the numbers, about 50 to 6 volcanoes erupt each year worldwide. Of those, about 500 million people live close to these volcanoes on average. That's 7% of the world's population each year is theoretically exposed to an erupting volcano. That's a lot. All right. In the U.S., usually we get 2 to 3 eruptions per year, mostly in Alaska and Hawaii, mostly out here in the Aleutian Islands, or the continuous eruptions of places like Kilauea. So most eruptions are in sparsely populated regions, especially Alaska. Hawaii, they kind of tend to know where the eruption is going to go, but every once in a while it surprises them. It flows a different direction. It squirts out somewhere new, and it can cause a lot of damage. Since 1952, Kilauea in Hawaii has erupted 34 times, so pretty consistently. It was erupting continuously from 83 to 2018, almost continuously, just constant lava flow. So they had a pretty good idea of where everything was going. Then it stopped for a couple years. And then all of a sudden it began erupting again, kind of picking up in a different area. It did end up kind of flowing into residential areas, burning some houses. I'll show you some images here in a moment. But for the most part, again, in Alaska and these islands, there's not many, if any, people out here. And in Hawaii, they tend to know where the lava is going to go. So not too much of an issue, here in the U.S. So when we're talking about volcanoes and the different types of volcanoes, there are different types of hazards. There's also primary hazards and secondary hazards. Primary hazards of volcanoes directly from the eruption, ashfall, lava flows, volcanic gases being released, pyroclastic flows, more on those. And then we also get the secondary hazards. The lava flow didn't burn my house. The eruption caused this other thing that destroyed my house. Things like lightning, earthquakes, floods, lahars, which are kind of like mud flows, debris flows, tsunamis, climate change, wildfires, famine, disease. So it wasn't the eruption that destroyed my home. The eruption, the landslide from the volcano went into the ocean, created a tsunami, and that tsunami raced onto the beach and destroyed my house. So secondary hazards. So let's first talk about some primary hazards, shall we? Before we do, let me give you another part of the super secret code. It is 325. You got me? 325. One more time, 325. Okay, so ashfall, lava flows, volcanic gases, and pyroclastic flows. Let's talk about each of these directly coming from volcanoes as a hazard. So ash, so when we're looking at a kind of a bigger explosive volcano, so we're talking Strombolian, or not Strombolian, but Strombolian, Volcanian or above. Excuse me, that's my fault. Volcanian, Palaean, or Plinian, you can get a lot of ash coming, or a lot of ash coming out here. So ash can cover hundreds or even thousands of square kilometers, big area. The vegetation in the area might be destroyed. Surface water can be contaminated by this stuff kind of settling onto water or even the ground. The ash is so fine. It's the very small particles. It can linger in the air for a while. It can affect the lungs of individuals. It can get in the gills of fish if it settles into water. Even though it's very fine material, it's still rock material. So you get enough of it built up on a roof, for instance, it can cause structural damage, things to collapse in. Even hundreds of miles away from the volcano, you get this ash, which is rock, eventually building up. Now you have a solid slab of rock on top of your house. It's going to be heavy. It's going to fall in. Again, it's an irritant to the eyes as well as the respiratory system. This ash is so fine and it's rock material. It's very jagged, small little particles, microscopic. But if you inhale those, it can just thrash your lungs. It can kill you, essentially. If planes fly through these ash clouds, it gets in the jets and the jet engines and just rips them to shreds, destroys them, causes them not to work. And guess what? Plane goes down. So planes can't fly when there's a lot of ash in the air from volcanoes. So again, we're talking about a lot of ash, and eventually it kind of raining back down. It's heavy. It can cause respiratory issues. You know, this is all ash on the ground. This isn't snow. So you can see even just a little bit of ash on this back part of the plane caused the whole plane just to kind of tilt back. It doesn't look like there's much ash back there at all, but you can see how heavy it is. You can see how heavy it is. It's crazy. So this is kind of an increasing amounts of danger to lives. Lava flows. There's a couple of different types of lava flows. One called Pahoehoe, which is a very smooth, ropey lava. It flows kind of quickly. And then A'a, which is kind of a slower, blockier, blobby form of lava. A'a moves very slow, kind of like a creep, like very slow, like kind of creeping forward, like literally kind of like this fast, like creeping forward. So it moves, you know, maybe an inch a minute or something like that. So very slow, but still moving nonetheless. Pahoehoe can tend to flow a little bit faster, 5 to 10 miles an hour. But in any case, these things are coming. You just get out of the way. What you can't get out of the way, houses, trees, buildings, infrastructure, roads, that sort of thing. It's also cool that lava flows can also produce lava tubes. More on that in a second. So you see here the thin, ropey Pahoehoe lava flow that can move relatively quick, again, burning houses and such. Here's a more jagged A'a flow, a little bit slower. So what you can get as these things are flowing, kind of a cooling crust on top, but underneath or below or in the center, the lava can still flow. Kind of, you can see it here. You see this crust on top, but below the lava is still flowing. After the eruption has ceased, it creates lava tubes, and we have plenty of those here in Arizona. So again, here's a nice flow of lava. This is from that latest Kilauean eruption. Again, people can get out of the way. It's not that fast, but there's no way to get, houses out of the way. There's no way to really get houses out of the way. It is what it is. So here's again going back to Sunset Crater. This, do you know what kind of lava flow does this look like? Pahoehoe or A'a? Looks pretty sharp and jagged and blocky. Most likely A'a, kind of sort of a slower lava flow. SP Crater, another cinder cone volcano here in Arizona. You see that lava flow coming out, as well as the lava tubes outside of Flagstaff. That's kind of northwest of Flagstaff, kind of out in the forest. You can get to these as well. It's cold down there all times of year. Bring a jacket, bring 2 flashlights. Volcanic gases. So these are any emitted gases from volcanoes. Water vapor, that's gaseous water. That's emitted from volcanoes. Same with carbon dioxide. Those two combine for about 90% of the emissions gaseous emissions out of a volcano. Carbon dioxide, it is, as a gas, is odorless and it's heavier than air. So what it can do is actually kind of sink out and flow, unforeseen, because you can't see it. And if it settles in kind of lower basin areas, a little kind of, maybe like a little lake area that's kind of like a bowl shape, this heavier gas can settle in there and essentially displace any oxygen that's there, suffocating people and animals that may be there. Sulfur dioxide is another gas that can be emitted from volcanoes, and that can actually produce acid rain. So sulfur dioxide, SO3, if it gets into the air, mixes with rain to create sulfuric acid, so you get acid rain raining back down. And when I say acid rain, I'm not talking about movie acid rain where it rains on someone's skin and their skin starts to melt off. No, it's very weakly acidic, but it still can do damage over time nonetheless. Excuse me. So again, emission of gases, acid rain, tied to, again, volcanic gas emissions. Now, with volcanic gas emissions, again, they can kill people. All right, they can kill people. In fact, gas is like the number 2 killer of a volcano. Gas is number 2 as far as common primary hazards. So, for instance, Lake Nyos in Cameroon, hotspot. Over 1,700 people and 3,500 livestock, cattle died due to CO2. This is one of those areas, kind of like this basin, kind of in a little valley surrounded by mountains. And this volcanic gas was released. It wasn't even like a big eruption. It's just gas found its way out from underground, from a volcanic magma chamber underground, made its way into this kind of valley, displaced the oxygen, killed everything. Everything suffocated. Nothing, no air, no oxygen to breathe. Just everyone just dropped dead. Imagine that. Can you imagine stumbling on that site? Everything just dropped dead. Odd. And then pyroclastic flows. The most lethal primary hazard of volcanic eruptions, by far. So you get this hot cloud of ash and rock racing downhill up to around 250 miles an hour, floating on poisonous gas, which is causing it to, which helps it move so fast. Red hot, burning cinders racing down the mountain. So it's going to crush you, it's going to burn you, it's going to poison you. Oh, it's the best of times. So pyroclastic flow. And you can't really get out of the way. You're not getting out of the way of 250 miles an hour. At nighttime, there's this glowing cloud of fast-moving ash and poisonous gas rushing down a mountainside. So if you live near or in a city near a volcano that produces a pyroclastic flow, typically stratovolcanoes, it'll be catastrophic. Catastrophic. And it's responsible for more deaths than any other hazard associated with volcanoes. So pyroclastic flow, hot ash, rocks, floating on poisonous gas, red hot, crush you, burn you, suffocate you, poison you, kill you. So here's an image of a pyroclastic flow racing down a mountain. Mount Vesuvius is a famous stratovolcano that erupted and described by Pliny the Elder, hence Plinian eruptions, basically named after describing the eruption of Mount Vesuvius. Pyroclastic flow rushed into the city of Pompeii in Italy, killing everyone instantly in the middle of the night, burying them, burning them. So So the town was lost. It was lost to antiquity, never to be seen again. And it wasn't until almost 2,000 years later, so about a couple hundred years ago, that people were excavating the town of Pompeii. And as they found the town of Pompeii, they started to find these pits. As they're digging, all of a sudden it was kind of an open pit with bones in it. And it wasn't really like graves. It was just these weird kind of air-filled pits with bones in them. And they found that these bones were kind of still in the shape of people. And so what they figured out is that this pyroclastic flow came in, buried everyone, burnt and killed them, and this is where these people died. And so as their body decayed away, their bones were left behind, leaving behind a cavity. So what they started to do when they came across these cavities was fill them in with cement and plaster. And so unfortunately, what they end up showing you is the last moments of these people. Kind of creepy. Here are some videos and examples of pyroclastic flows. Please watch these videos. I'm going to pause here. When we come back, we'll talk about secondary hazards. See you in just a minute.